Hello there, welcome to the October 2020 applied paper. Here we're looking at question 8. A particle P moves along a straight line such that at time t seconds, when t is greater than or equal to 0, after leaving the point O on the line, the velocity v meters per second of P is modelled as this expression here. Find the value of t at the instant when P stops accelerating. So if we want to find when P stops accelerating, we want to find when A is equal to 0. So in order to do this, we need to differentiate our velocity. So the first thing to do would be sensible and expand the velocity formulae. So it's going to be minus 2t squared, 7t minus 40, that would be plus 3t, and then plus 14. So now we need to differentiate it, and when we differentiate it, we find acceleration. So that's going to be minus 4t plus 3. So therefore, we set that equal to 0, so minus 4t plus 3 equals 0. So therefore, t is going to equal, we'll move the 4 onto the other side, and then divide by that 4, so it'll be 3/4. So 0.75 meters per second. No, sorry, no, not meters per second, it's seconds as our unit for time. Good, moving on to part B now. Find the distance of P from O at the instant when P changes direction of motion. So when P changes direction of motion, it's going to be when our velocity is equal to 0. So it's going to be the velocity will be 3.5 when it turns around. So V equals 3.5. So let's find the distance of P from O at the instant when P changes its direction of motion. So with this one here, if we want to find distance and we have velocity, we actually need to integrate it. So it's going to be s equals, the distance is going to be the integral between 0 to 3.5. That's from the distance from O, that's at time O, and the instant when P changes direction of motion, that's when V equals 3.5. And that was a solution to this equation equaling 0. So when it turns around, the velocity is going to be 0. So if you imagine a particle when it then turns around, at that point here, its velocity was equal to 0 because it isn't moving at all at that point. So I just set the velocity curve equal to 0, and in that bracket I got 3.5. In this bracket I'd get minus 2, but that's not possible because t is greater than or equal to 0. So I get 3.5 as my point in time that I'm going to turn around at. And now I need to integrate this curve here. Okay, so let's work out this integration then first. So it's going to be minus 2/3 t cubed plus 3/2 t squared plus 14t, and integrate that between the boundary of 3.5 to 0. Sorry, not integrate it, but substitute it in. So we'll substitute 3.5 in and 0 in, and then do 1 subtract the other. So when I do it on my calculator, I think I'll probably do it all in one go here. If I do it all in one, we're going to get s equals 9. In fact, when you put in 0, you're not going to get anything, so there's no point in doing that bit at the back. We're going to get 931 over 24, which is equal to 38.8 meters when you round to 3 significant figures. And there we are, that's our answer for question 8 there, worth 9 marks in total. So this is a classic question that they ask in kind of A-level questions, whereby you take your velocity, and if you integrate, you get back to displacement, and if you differentiate that, then you get back to velocity. And if you're at velocity and you differentiate with respect to t, you get to acceleration. And if you want to come back, you integrate. So there's a link between distance moved, or displacement, velocity, and acceleration by differentiating or integrating. So there we are, that's our answer for question 8, and that's the end of the paper. So best of luck with your exams in 2021, if you are taking exams anyway. And otherwise, if we have taken the 2021 series already, then maybe you might want to move on and have a look at some of the AS applied questions from 2021. Thanks very much everyone, hopefully you found these videos helpful.